You've probably heard of machine learning by now. It's one of the most important and rapidly advancing fields of our era. But it seems weird to think about for most people initially. How can machines actually learn? The answer is machines can only learn with a teacher, and their teacher is data. Lots of data. As an example, take this little plot with three separate classes. Our machine's job is to draw lines in it so that all the classes are in their own section of the chart. By doing this, our machine can know what class future data is likely to be based on what section it falls into. We need to give it some guidance, however, on how to determine what the best lines are. Let's take a few of them intuitively, then see what the good ones have in common. Consider this line. It's 100% pure red on the left side, so any new point on that side is likely to be red as well. A line slightly to the right, however, does not achieve purity on any side. We therefore need to find a mathematical definition of our notion of purity. If we have only two classes, A and B, then the definition is simple, just P of A times P of B. That is, the probability that any two selected elements will be of different classes. The lower this number, the more pure the set is. This can be extended fairly easily to any n number of classes in the dataset. In this example set, we can take each class one at a time and classify everything else as other. Since these new sets have two classes each, we can apply the two-class purity measure to each of them and then add their scores up. For the first set, the other is everything that is not A, that is 1 minus P of A. So the purity measure for the A set becomes P of A times 1 minus P of A. Doing the same for the B and C sets, you get an equation, which can then be shortened into a generalized summation. With some simplification, we arrive at a concise purity measure, 1 minus the summation of each class's probability squared. It's called the Gini Impurity, named after this incredibly serious Italian, Corrado Gini. Using this impurity measure, machines can learn what makes each class unique and become immensely useful in further endeavors. But this is only one of the ways this can happen. More advanced versions of this algorithm have been used in video classification for YouTube, product recommendations for Amazon, and spam filtering for Gmail. Humanity's journey to a superintelligence has only just begun, and by understanding this simple building block, you've come one step closer to being a part of it.